Let's continue our discussion of types of energy right now with potential, and we're going to focus on just one of them in this video. It is gravitational. And as you can see here, gravitational also has an equation just like kinetic does. So make sure you have that calculator out, ready to go. So as you recall, kinetic energy is looking at energy of an object in motion. What potential energy is looking at here is kind of the object, energy that an object has before it's moving or when it's about to move. So it's essentially not moving currently, but it's got energy, here's the key word, stored. So it's got energy stored within it, and typically that energy is stored due to the interactions between two objects. So potential energy is energy that's stored due to interactions between objects. And again, there are three types of these: gravitational, chemical, and elastic. This video is going to focus just on gravitational, which we have a calculation for. So again, make sure you have that calculator handy, ready to roll. So as you can maybe guess here by the name, gravitational potential energy does have something to do with gravity. Gravitational potential energy is energy that's due to gravitational forces acting between two objects. And so essentially every object does have gravitational potential energy. And there's dozens, if not hundreds of millions of examples. So we just have a few on our slide here for you to record. You can use any of these on the right side, either write them out or draw them out. But you right now, like this guy, have gravitational potential energy sitting in a chair. Gravity is pulling you down, sitting in the chair, so between you and the chair, there is gravitational potential energy. We also see it here with the apple hanging on the tree. Between the little stem here and the apple, there's a gravitational interaction, as well as the bird sitting on the perch right here, similar to you sitting in the chair. So any object at rest on a surface has got gravitational potential energy, or between two objects. So if we look at this bookshelf, you can go ahead and pause and just kind of think about it, maybe record one of these as your examples. Which of these objects here would have gravitational potential energy? So if we look at them, we've got dozens of examples right here. Any book on this bookshelf, any vase, even the flower in the vase, those two have gravitational potential. We could say even the bookshelf on the floor or these slippers on the floor, right? Any of these things have gravitational potential energy, which is stored energy between those objects. So we are able to calculate potential energy using a formula. And this formula is a little bit simpler than our kinetic formula. There's no squares involved in this one. It's just three things multiplied together. So we have m, which should look familiar from our previous, which is mass in kilograms. We have g, and this is the one that's going to be a little bit different. G is the acceleration of gravity, which is a constant, meaning it doesn't change. Right? This is a constant that will always use this number 9.8 for G as long as we're measuring things here on Earth. This is the calculated acceleration of gravity of any object. So we have mass as the m, G as 9.8, acceleration of gravity. Think about what the h might represent. If we look back to that image of the bookshelf, we might consider something different between items on shelf 1 compared to shelf 3. So h, what h is measuring is the height of the object, and we simply measure the height in meters. Can record that unit in. Notice that any calculation that we do for potential still comes out as capital J or joules when we measure that final answer. So let's try it out. We've got a word problem here, again, underlining key things to plug into our formula. This time we have a monkey hanging on a tree branch, similar to that apple example. The monkey has a mass of 1.2 kilograms, hanging from a height of 6 meters. So again, I use my information and I plug in what I have. Mass in this problem is 1.2 kilograms. I also have my height here, which is 6 meters. But that's it. I don't have a G value, so I have to kind of figure out what might that be. And thinking back, that G we said is acceleration of gravity. That's a constant, which means it's always the same. So no matter if I see it in the word problem or not, my G is always going to be a value of 9.8. So if we plug each one of those into the formula here, you can calculate that out and solve for potential in joules, capital J. Again, one more practice problem, working through finding the values in the problem. We've got a 0.2 kg pigeon and a 15-meter high telephone pole. Again, you know G is always going to be constant, so if we solve those out, we have M times G times H. That's what we're looking at. So plug those in, solve it out, and get your answer measured in joules. Awesome. Finally, let's do a little compare-contrast between the two, KE kinetic, object in motion, and PE potential energy, object not in motion, with the potential to have it. So reading through each scenario, we want to determine which is KE and which is PE by recording it here on the blank at the bottom of your notes page. So the first one here, we have a Great Dane, which is a dog. Here we have a value for mass. That dog is running and jumping into a lake with a velocity of 10 meters per second. So two things, think about what the object is doing and think about the two values that we have for our formula. You don't have to solve this, just record either KE or PE on the line. Next one, I have a bird, again a value of mass, at rest or sitting on a 20-meter high telephone pole. Again, determine is that a KE or a PE. And here we have a skydiver reaching a speed of 370 meters per second, jumping from a height of 39,000 meters. So think about what the object is doing and record KEPE on the line. So you are complete with this video if you have done the following. You have all the blanks on the left side filled in. You completed your examples for potential energy on the right by either drawing or writing them in. And then you've also completed or calculated through both PE practice problems and then completed the KE PE problems at the end. There were 3 of those to fill in the blank. If you want a little bonus at the end of your notes, then draw this little happy face down in the bottom corner underneath the hole punch. Thank you.